So I bet that you were all wondering what the countdown was for. Sorry, no great reveal. Cullen, I'm speaking. Hopefully that works. Welcome to Sframe. I think this might be our first, second formal meeting. Happens like that sometimes. I'll be chairing. My co-chair Bobo is probably happily sleeping. Sorry, I can't say the same thing. I'll turn my video off so you don't get to see my bleary, sleep-deprived face, and we'll get into the meeting. So I'm just going to go through a few slides. We'll talk about the agenda, and then I'll see where we end up. Everyone's read the note well, hopefully. It's on the slide in case you haven't. It's on the website in case you actually care to read it. So I don't have a hugely long session this evening or this morning or this afternoon. So we have a few short presentations. After some discussion on the list about the big picture stuff, I thought it might help to get someone to do a bit of an overview of the use cases and the scope. So we actually had two presentations on that. I think Tim's going to be talking about the meta level questions. And Dr. Alex has presentations on how the technical pieces all fit together. Then Sergio has the draft on a proposal that's now in AVT core, and we'll give Richard some time to talk about the MLS integration as well. So nothing all that exciting there. In terms of status updates, not a lot to say. Oh, I should say, before I go on, does anyone want to bash the agenda? Anything else? I think that since there was so much excitement on the list, there would be someone wanting to say something, but nevertheless, we move on. Yeah, not really. Not a lot's happened in the past little while, and we're kind of hoping that that will change. But we had a good meeting last time, and so maybe we can have a good one this time too. I'm going to pass off to Tim. I'll drive the slides and
so with any luck, my audio is working. Yeah, I'm going to assume it is. Somebody will tell me if it isn't. So yeah, Sframe scope and use cases. Kind of trying to stand like a few thousand feet above this and kind of see what's going on. And I based this on a little bit of implementation experience that I've had, but also listening to what the Jitsi people have done. And they've spoken publicly about their implementation experience and what they needed and whatever. So it kind of comes out of that. Next slide, please. So to my mind, and I think this is something that we can like all discuss in a minute because it's got 10-minute slot and only 2 slides, so we should have time to discuss this. To my mind, there is only a single use case, and that it is for selective forwarding units. What we're trying to do is to protect, I mean, the like really high level view is that we're protecting your data from your service provider so that, you know, Alice and Bob can have a private conversation without their mutual service provider having to be in the media stream in terms of being able to comprehend it. The flip side is also true. You're protecting the service provider from your data. So the service provider is given, let's say, plausible deniability about whether they were exposed to your share dealing plans or whether they saw your patent before it was filed. So it's kind of two-way protection here. And the SFU, like the clue in the SFU is about selective forwarding. It's selective about what it's trying to forward. It gets a lot of stuff from the sender and it only forwards some of it to the receivers. And so it's doing an impedance match between the source and the sink in effect. And that's typically at the level of either bandwidth, because not all the recipients have the same downlink. Like some recipients have got much more downlink than others. And likewise, the resolution, some of the recipients have different screen sizes from others. And so basically the SFU is faced with the question of like, which of these packets I've received that I want to multiplex out ideally to everybody, which of them can I drop to somebody who can't cope with all of it? And that's the, like what we're trying to do here is to support that. Can we move to the next slide, please? And so that brings us to the scope and to my view, again, I think like what we should be doing here is as little as possible. Like we're in a hurry. This stuff is shipping. Jitsi have already got people doing this, and the risk is that people are going to hand roll the encryption for this use case. And there are some tremendous foot cannons here that, like, as true with a lot of encryption, but in this case, there are some really wonderful ones. So I think what we need to be doing is describing what the unencrypted SFU receives in terms of info. So what it can see that then would then allow it to decide what packets to drop. And potentially also it's useful for it to be able to decide when it can drop those packets, because there are some points where it's more useful to like switch layers or something like that. And it may be necessary for it to understand what it should or could cache in terms of things like keyframes or last X packets per layer. And that's, to me, that's the total scope of what we need to be doing here, just describing these things and deciding what they are. And kind of, can't actually think of anything else that should be in scope. And I guess so the purpose of this presentation is to put those two questions out there. Like, is there more to the scope than this? Is there more to the more use cases than this? And if so, what are they, and do they fit within the charter? And that's kind of pretty much all I wanted to say, I think. So I'm looking to see if anyone raises a hand.
Yeah, that's what we're waiting for. Oh, look at this. It begins. Jonathan.
I think I agree, but I think that there's probably more foot cannons than you anticipate. Which is to say, there's, you know, when you describe the unencrypted info that SFU gets, there's probably some foot cannons there too, which is to say, both in terms of sending too much, that you end up accidentally exposing information, because basically encrypted media, especially encrypted video, is pretty complicated. And so both in terms of, you know, accidentally encrypting something that turns out the SFU needs, and accidentally not encrypting something that, you know, you actually exposes something that you weren't anticipating exposing, are both potentially complicated issues here. So there's going to be a lot of, this is, you know, going to be a fairly hard problem, at least to do in, you know, in generality and interoperability, with good interoperability, as opposed to I know what I'm, you know, I'm only doing this codec. I know that means I send bytes 1 through 6, and that's safe, you know, with my encoder implementation, and done.
Yeah, I mean, I totally agree that there are huge pitfalls to fall into here, but I think that the one that we've already fallen into is not abstracting enough, which is why I wanted to do this like very high level view, is that I think that like we really are looking at what packets to drop. And to be honest, if you don't drop a packet that you should have dropped, or you do drop a packet that you shouldn't have dropped, it sort of doesn't matter as much as you might think, because this thing is all over a UDP anyway. Like, it's not a precision thing. And if you send more packets than you should have done, they're going to get dropped by somebody else. So I think there's been an overemphasis on precision here, which I think is unhelpful. I think we can be more general and less accurate.
That's true, but that does imply things on right now. I think there are certain assumptions that the ultimate decoders make about their media that that there is a certain precision in it, that that it's going to be reasonably self-consistent about what's in it, and gaps are semantically mean that something is you needed is missing, and so I think that.
But that's what that's fine. For. That's what a knack is for.
Not if a knack was something that turns out that something you dropped deliberately, and then the other side thinks, oh, it needed it, and then so it doesn't. Yeah, and those. So I mean, there's if the receiver thinks a gap means something was needed, and the sender thinks, oh, a gap is just because I chose not to send that to you, and they disagree, and the receiver doesn't move forward, then you have a problem. So that there's I think this imposes more requirements on understanding potentially messy streams on the ultimate decoders than we currently have. Right now, there's a sort of an assumption that the SFUs clean up a lot of mess, which, given this environment, they can't. So I think that needs to be understood.
Yeah, but I don't think that tells you how you have to solve that problem.
No, it doesn't. It's something we're going to need to look at and decide. And I think that's something we're going to need to actually decide and make explicit that, if you have a existing implementation that assumes a reasonably clean stream, well, if you're doing Sframe, sorry, you don't get that. You're going to have to, deal with mess.
Thanks, Jonathan. Bernard.
To underline Jonathan's point, one thing that I don't think it's been written down, but decoders can be very finicky. An example is VP8, where the picture ID not only has to be monotonically increasing, it has to be sequential. And what that means is if you drop a frame, even if it's discardable, it'll cause the decoder to find the stream undecodable. And what that means in practice is that the picture ID has to be rewritten by the SFU. So there are a lot of codec-specific complexities here. So if you say we have to create metadata that works for all codecs, I don't know that that's really possible. We haven't shown ourselves able to do it yet. And there's been at least 3 attempts to achieve that. The other thing is about the use case itself, which seems to assume that the service provider is separate from the application provider. And the problem is that that's a business model which doesn't really exist to any significant extent. So if you look at all the major products out there, the SFU provider is basically the same as the application provider, and that creates a whole lot of problems if you're serving JavaScript, which actually is in possession of keys, and then you're claiming you'll get any additional security out of that. That's not really true.
I mean, totally, and hence to the second point, totally, and hence the wording about kind of plausible deniability. It's not an absolute. It's merely moving the needle, but it seems to be a moving of the needle that people want. Now, whether they're right to want it or not is kind of almost not our judgment point.
I think the actual real problem is something quite different. It's really attacks on virtual machines by other virtual machines, right? It's Spectre and all of that stuff. That's really what the real issue is. Yeah, it's really So that probably should be said. Anyway.
And I think just to cover the first point, I think there's an assumption there that rewriting has to be done in the SFU, which is kind of, there's this tacit assumption that the SFU will do everything it has to do so that the decoder at the far end doesn't know that Sframe is involved. And I think what we're starting to hear is that may not be possible.
Okay, thanks, Bernard. Stefan? Oh, and by the way, I'm cutting the queue here because this session has only a few more minutes left.
Good morning. Is it now working?
Yes.
Okay, great. So I count the same horn here that Bernard and Jonathan had. I would suggest that it's basically impossible to do this in a generic way. I would suggest to add to the requirements that there should be codec-specific restrictions on the codec bitstream complexity. Things like, okay, if you're using HEVC, you shall not use gradual decoder refresh. You want to have a keyframe, otherwise the concept of keyframes and keyframe caching is meaningless, right? Things like that. Then you may have a chance. I'm not optimistic even with that, but you may have a chance. Thank you.
And next is Magnus.
Yes. So I want to turn, I think, the question around. Is it really decide what to drop? Is it decide what to forward? And because from my perspective, we are talking about media streams here, and that's maybe the high level assumption, at least, is that there are several media streams. It's not just one set of packets that you have to select some random set, but we actually have some underlying structure, and that still comes through here, I think, even with S-frames, because you need to preserve that some information internally and some for the SFU, but the source and the receiver needs to understand these things, and I think that's part of the complexity here. Is we need to have a model, and we need to have saying, okay, what general type of structures are we supporting and handling in an SFU context, and that's where you come down to. So
That's an assertion, but I'm not totally certain that it's true. I mean, if these things are happening over a UDP network, and we built the rest of it such that arbitrary things can be lost and it should work, and I'm puzzled that saying that dropping isn't good enough.
But so on that, I mean, that's the other aspect. I didn't bring it, but so unless you have congestion or saying if resource shortage in the bandwidth, okay, fine, you can send everything. But the moment you have constrained amount of resources and you need to confirm to that, then you need to select a set which works. And if you're going to drop random things, you're going to get to something that doesn't work, because you are not going to be able to, if you completely random drop, you have a certain probability of it being able to repair it in time or not, or otherwise it's late. And that's what you end up in. So
right. So what we're trying to do is improve on random. And my point is that we don't have to be perfect. We just have to be better than random, and we like,
yes,
that might be good enough.
Yes, but be able to repair it means that you actually need to understand if something that was lost is something that's useful for you, which means that you have to have structures that tells you that the things that didn't arrive was something that you needed. And that is a particular part of the problem here. Because if you don't know that this is an RTP stream at a certain layer and that you lost something, you either need to make a decision. Do I need this layer? Could I drop the whole layer? Or is this the base layer? And for a stream I actually want to show, then I need to request getting this. And you need to understand the difference between those two to be able to repair.
So you need some categorization, which could be opaque, but it needs to be categorized.
Yes. And you have to have that structure showing up. I mean, that's what RTP does to you if you use it correctly today. And that needs to be preserved when you put S-frames in RTP payloads, so you can understand which things you did care about or not. And if the was related to not to something you cared about, even if it's only the receiver or the sender that knows if it's useful in which contexts. So, but I think that's enough.
I think that's a good point. Thanks, Magnus. Phil.
Yeah,
thanks for being patient.
It's not often that I get to make an end-to-end argument here, but I'm not working in WebRTC or whatever, doing stuff that is entirely greenfield research. I don't see the reason why the reflector needs to know anything about the semantics of the streams, provided that the data is packaged up into different streams so that a selection can be made at some point, and provided there is some virtual or singular authority somewhere that is saying what the streams are in such a way that the consumers of those streams can make a choice. I think that is sufficient to be able to solve this problem. So say I've got a phone that's on a weak link, that can make the choice of which streams it is going to consume. And it's only that end device that can make decisions like, oh, I didn't get this packet, but I'm not going to ask for a repeat of that packet because I've already shown the next frame to the end user, or I'm going to drop all that traffic and just resynchronize. And so I think that casting this more in an end-to-endy sort of fashion and looking at the service provider just having a black box that doesn't understand anything about the data that's traveling through it, other than that it happens to be tagged into these separate pieces. I think that's a better way of looking at it. It certainly helped me. And that's it. Yeah.
Thanks, Phil. Mo, I think you're the last in the queue before we move on to the next topic.
Yeah, so a higher level question about this slide, the scope. Looking ahead at the other presentations, I sense a little mismatch. I'd like to make sure that the group understands which way we're going. Clearly this all started from being able to just support end-to-end encryption, but I think a lot of the mechanisms that are being proposed are really about insertable streams in general, transforms on the media in general, packetization formats for RTP in general. So I wonder whether or not the group is going to favor general solutions or maybe even prohibit a general solution, or not. Are you really only focused on providing the end-to-end, secure media solution? And is it a goal or a non-goal, or explicitly don't want to support things that are more generic than that?
I mean, to the extent that's a question for me, which it kind of isn't, because it's a question for the group.
No, it's for the
so
whole
I
group,
guess we
yeah,
should take
whole
it to the list. But my opinion is we're in a hurry, and we should limit this as far as possible. If it happens that an easy solution that's generic drops out, then that's great. But I think the idea that we should track insertable streams and make them a dependency on this would be a mistake. I'm hoping for another opinion.
I'm thinking we might have to take this to the mailing list, and hopefully Dr. Alex can get himself in queue and we can have a discussion about the next thing. Bit unfortunate because that was going well. Thanks, Tim. Got things rolling. I would encourage people to write down their thoughts and put them into an email that we can talk about, because no emails is much harder to work with than emails. So, slides.
Right. So, as one of the author of the original document and all the subsequent documents since, and of the charter, we've been requested during the charter part of Sframe to give a big picture document and to show which part belonged to which group. As in the past 20 minutes, many people pointed to, there are parts that are media encryption, and there are parts that are RTP packetization, payload question, and so on and so forth. So I'm sorry I couldn't come up with an informal draft yet, but it's going to come next. And that's why the first slide is about AVT Core, Sframe, and in part WIP, where we're going to put all the excellent question and problem we have within their respective working group, within a global picture, and hopefully within draft. So some of the draft didn't exist last time and are going to be cited and are going to speak about in this session later by Sergio and by Richard on specific points. But the big picture, I think, is needed to avoid the 20 minutes we just passed. Next slide. So just looking at the original WebRTC 1, which was supposed to be P2P, we had something like this, which is very simplified: a source, an encoder, an RTP packetizer, the SRTP part with the key creation and the key exchange, and then a transport. So it's simplified. It's a little bit more complicated than that. I put some of the RFC, obviously not all of them. And this is what the RTP redundancy and congestion control can look like with the PLI, SLI, and everything that fits into the profile. For simplification, I'll also show only a single stream. I don't go into simulcast and SVC until the end, until the last slide. Next slide, please. So very quickly, we had to add the media server. So it's a truncated way of the media path where we don't put the receiver. We just put a sender, a media server, and a receiver. And each of sender, media server, and receiver act like a WebRTC peer. And so now what was an end-to-end encryption in P2P become a hop by hop. We can see exactly the same thing. For illustration purpose, I show a little red arrow to position where WIP, which was the discussion 2 hours ago, should be, which is the signaling protocol on top of JSEP when the sender and the media server are sending one way. And you have exactly the same thing. In that case, you have small modification in the sense that if the media server is an SFU, you do not need to manipulate the media anymore. And what you do is mainly duplicating the RTP packet and modify the RTP headers, adding RTP header extension, and a certain list of things. So in addition to the original WebRTC spec, now we have Trickle, we have PAC, we have IceLight. We can cite also 6904, which was the first header extension encryption, and the Cryptex proposed draft by Justin that will be presented at AVT Core. Next slide. Now, if we want to add end-to-end encryption of a WebRTC, multiple steps are needed, right? First, you need to add an additional filter between the codec and the RTP payload. And that's what the draft at VT Core about codec agnostic is made. And there will be a full presentation by Sergio and UN on the topic. Here, this is the IETF point of view. There is nothing about the web. And this is what's going to be presented at VT Core. Next slide. Now, if you look now, if you assume now that the media is encrypted, the media server might not be, the existing media server might not be able to do the job they're doing today because they depend on access on the RTP payload header. And so you need to decide which information the SFU needs and where to put it. So far, the idea was to take the information needed in a structured way and to put it in a RTP header extension. 1 or 2 years ago at AVT Core, the decision was that any new RTP payload should support frame marking. There is a question mark today whether frame marking is enough or not. And yes, there are some questions open about what information should be put there. Are we backward compatible or forward compatible? And with the new RTP payload for H266 by Stefan and the other authors, or AV1, we come with SVC codec that had a layer of complexity which needs to be dealt with in the SFU and was designed for that and cannot be dealt really end-to-end. So now you have two antagonist thing, which is I want encryption as much as possible, but I still want an SFU. If I don't have an SFU in the loop, I'm still P2P and I'm end-to-end encrypted, and then I'm done, right? So one of the first questions still unsolved that will require discussion at IVT core is, what do we do in that RTP header extension? Next slide. The second question is, now I need to exchange a key end-to-end as opposed to exchange a key hop by hop. How do I do that? So here, the exchange of the key and how you rotate the key and so on is orthogonal to really the media encryption. So the Sframe group was charted to define a media encryption independently of the use case and independently of the key exchange. A little bit like in a PERC group, you have a difference between the double document and the three other documents that were all together designing a system. So Sframe is media encryption only. Now, depending on your application and depending on your use case, video conferencing being very different from streaming, one-way streaming, for example, you might want to use different systems, but in all the case, what is clear is you need a key management system that is separated from the endpoints on one hand and from the SFU on the other hand. You need to have the three of them separated. So there is a proposal by Richard, by Cisco, to do the key exchange using MLS. There is corresponding implementation in Safari with extra additional security things because of the web threat model. And there is another implementation using OLM by Jitsi. I think Saul is in the call today. Maybe he will tell us a little bit about that. And I'm pretty sure that WebEx is doing things pretty differently, but they all fit that diagram where you need to have a secure way to exchange the key, and the key management need to be external. Next slide. Now, if we go specifically into insertable stream, and by the way, the name has just changed, so UN can tell us what the new name is. I'm not sure what it is anymore, but the idea is now in a web application, in a native application, you control everything, but in a web application, the trust model is different. You do not trust the JavaScript. With the traditional WebRTC implementation, with the traditional WebRTC implementation, the key is generated by the user agent. It's never passed on by the JavaScript, and so we're good. Now, we need to find a way to apply that Sframe transform and to get the key directly in a user agent, right? So here, we're going to create an API called Insertable Stream API until this week that will allow us to inject encrypted content to the RTP. But we haven't solved the problem of the encryption and the exchange of the key outside of the JavaScript. So this is where the Safari proposal for an implementation in native worker that is not accessible by JavaScript makes sense. So next slide, which is the last one. If you put everything together and you put it in Police 6, which is absolutely unreadable, this is what you get. So the little difference is the dotted white block is the Insertable Stream API, where you're going to plug in the Sframe transform, which is protected in the C++ part of the browser, in the user agent, and then the external. So now I'm going to let Sergio and UN explain a little bit more on the RTP packetizer problem, and I'm going to let Richard speak about the MLS for key exchange. We can skip that for now. So this is that was a specific slide to answer Magnus and Colin question about does it disrupt any of the RTP or anything. So we went through every single RFC one by one and we implemented them, and it doesn't look like it, but we might have missed a few.
Okay, thank you. Are there any questions based on this, or is this just reiterating people's understanding already? Great. Sergio, grab a mic.
Yep. Well,
yours.
these are the slides that are going to be presented tomorrow on the ABT core. So, well, not sure how it will go, if we will have the same discussion today and tomorrow, or we will. I hope that we are focused on different angles. But so I will.
So
yeah.
Maybe given that you have half an hour tomorrow, I think it is, then you can go through and maybe you can talk about the high level concepts, and we can try to focus in on those questions that we were talking about earlier with Tim's presentation.
Mm-hmm. Okay, so next slide. So the first is like the continuation of the presentation that Alex has done, is that really with Sframe, what we are doing is inserting a new element in the RTP and in the media chain as defined in the RFC 7656, the RTP, how it was called, the taxonomy RTP. So what it introduces is a new element that does the transformation, that transforms the encoded stream that comes from the encoder before it gets to the packetizer. So typically the packetizer expects the stream to come directly from the media encoder, so it can do so it parses the media stream and its frame, and for a specific codec boundaries and information, and it then transforms it into several RTP packets. If we apply Sframe or any other transformation that changes the content of the or encrypts, for example, in this case, the content of the media frame, then the current packetizers cannot work with the byte stream anymore. And what you need to do is several hacks based on each codec to make it work with Sframe, as I presented in the last IETF, in the last Sframe meeting. Yes, Tim is on the queue. Tim?
Yeah, so can you just back up and tell us why you have to do the packetization after you've done the transform? Why can't you do that the other way around? I'm sure there are good reasons, but I think they're worth stating.
This is something that I mean, this is how Sframe works. I mean, we can. I should not be the one. And
media transport agnostic.
Yeah, I mean, there are several. I mean, this is how Sframe works. Now I can explain why Sframe works like that. Is because it is has less overhead when sending it over the wire, because the encryption data associated with the frame is sent only one per frame and not one per packet. So the overhead is lower, and also because as Alex has said, in this way, Sframe is agnostic to the media transport and can work with RTP and, for example, with QUIC. And this was one of the reasons that Sframe is working on a per frame basis and not on a per packet basis. Bernard?
My question is, when you say the current media packetizer doesn't support this, is it really because of the packetizer, or is it because of the SFU that we have these hacks? I think it's more the SFU, right?
It's really both. I mean, for example, you cannot. I mean, to make it work, BP8 and BP9 are rare cases because there is not much mangling of bytes when you do the packetizing. But for example, H.264, you cannot apply directly to the frame, because you have to parse the null unit. So you have to do a lot of specific things in the media frame in order to create the packetizer. So it is a bit of both. I mean, both things that are needed in the SVU, and also things that happen on the packetizer itself.
Yeah. Also, you know, I think it's assumed here that the transformer doesn't really communicate with the packetizer in any formal way. I'm just questioning whether that's a hard requirement. I mean, that's how insertable streams works, but it also creates a number of problems in that if you increase the data size for some reason, now the packetizer doesn't know what's going on. So anyway, I would just question whether I think this is a slide about the actual architecture that's shipping rather than the architecture necessarily that we need. So that's just a question.
Yeah, I mean, this is how it is implemented today and how is, I mean, we could have it other ways, but the one that we have today is this one. Yeah, Magnus?
So, yes. So I think this picture is oversimplified, and what we really have in this case is that you have a packetization step in some sense prior to the media transform, and then you have a second packetizer afterwards, because you need to, let's say, the media encoding is outputting some data, but in reality, if you're talking about scalable video codecs, for example, you're not putting out one encoded stream, you're outputting multiple encoded streams. And you need to packetize those individually and with the right amount of metadata, even internally, to be able to figure out where it belongs to. And then you transform it into the protected form, and then you packetize it again for the transport, just to fit RTP in that sense. So I think we have to be very aware that we're actually having several steps here, and what you packetize before you encode is an important question. But okay, in this case, it often happens and ends up in the, especially in WebRTC, it's going to end up in the implementation in maybe in JavaScript domain. But it's highly relevant. So.
But you say that this picture is not correct, or should be more defined?
I think it would be good to try to take some case of actually providing more, take a scalable video codec and look about how you're actually going to do this and what it looks like, because then you end up with this when it becomes a fork in the media after the media encoder step, because the media encoder.
Yeah, SBC and simulcast is specifically worked out in the draft, and I think that I have a slide later on.
Okay, good.
Colin?
Yeah, I mean, so this is certainly one possible way one could implement it. One of the decisions we made fairly early in the design of RTP, and that we have reflected in all of the payload formats that have been defined, is specifically not to build things, or not to try to build things in a codec agnostic way. And to specifically not build, to try to do the packetization in a codec agnostic way, because the information, you need the information that's codec specific to do this effectively and to make something that's robust. And I'm wondering if there are ways which would fit the RTP model better, which did this in a way which, did the encryption of the contents in a way which reflected knowledge of the particular payload formats, and that would then simplify the rest of the design, but by encrypting in a payload in a codec aware way rather than trying to do this in a codec agnostic way.
There are three problems with that. One is that first, that the specification work will be endless, because you will have to specify how to encrypt each of the video and audio codecs. So we'll have to do a lot of work to just specify how do we need to implement to do Sframe encryption in H.264, H.265, H.266, PP8, PP9, AB1, AB3.
I mean,
so
this is true, but I think you're going to do that work anyway, and you're just going to do it piecemeal over a long period of time as you realize the robustness problems. And I think if you do if you assume that's the model up front, you are at least aware of the complexity that's needed to make this work effectively.
The only thing about the robustness is that at least in WebRTC implementation, we are not using that so much. So I mean, while RTP is implemented or has defined it into a very details, for example, as uses for slices, I have not seen any implementation that it is really using it a part of in a very codec specific way, just about RTP, NAX, FEC, and things like that. But I have not seen much fraction of a per codec robustness thing. So this I'm not sure.
But I'm seeing a bunch of people in the chat and the comments Magnus was putting in was saying that this is needed to make the selective forwarding work. So I'm not sure this is necessarily accurate.
Well, I have to implement this.
Just because some implementations are poor quality, I think doesn't necessarily mean that they all need to be.
I would love to hear more about how that it is used and how it is done or where it is done, because at least in the CUs that I know, it is not also done. So if Magnus can provide more details about how this codec specific robustness is used in SVUs and something like that, I would really like to see it. I mean, because right now in all the SVUs that I know, it is not the case. So
Sorry for barking, and I trying to understand. I think we're misunderstanding each other maybe here. So I understand, what are you trying to say that I have said? I didn't really understand, because when I'm talking about detecting losses, I'm talking about that in the classic RTP, which is on SSRC level. You can see a gap for a particular SSRC in the sequence number space. And then you know that you're missing something. And if you mapped one SSRC to one stream or layer, in certain case, you would know that, oh, I'm missing this. I know that people have, in many cases, implemented with scalable codecs. They do maintain part of the structure, saying, okay, at least in the higher levels. And in some cases, you smashed everything together and say, okay, I'm going to repair and it select and assume that the SFU done the right thing. But with S-frames, you're not having that insight into this as easily. You probably want to have more SSRCs so you can see that you lose a particular layer that you're forwarding, so you can try to decide if you're going to repair this and know that this is a particular layer for a particular source. That's what I'm meaning.
Yeah, and I agree with that, and this should be covered with this packetization format. I mean, I hope that we are able to cover. Kalen?
I was just trying to reiterate the point here of that. I think what I heard from and Magnus is, and I totally agree with it. I think we just need to think about it this way, of that in your picture, like if you zoom in on all of that, where the encoded stream goes into the media transformer, it's not really a stream. It's already been basically packetized at that point. And there's that encoded stream actually is packetized in some form before it even comes in. And that packetization is inevitably codec specific at some level. I mean, you have to implement different code for different things there. I mean, I get audio separate, but I'm talking about scalable video type things. Mm-hmm. So I think if we just sort of reflect on that's already sort of happening, it sort of maybe rechanges how you frame and think about this conversation.
Well, yes and no. I mean, I agree with that. What it comes up with from the media encoder is packetized, but in a frame way. So it's an array of bytes. I don't really need to know exactly what goes inside these bytes to be able to package that.
Scalable, you need to know a little bit more than it's a chunk of bytes. Than it's array
I need to know I need to know some metadata, but I don't need to know the actual format. So yes, I need to know this metadata. So if it is an iframe, if it is some other stuff that it is later on in the presentation, but I don't need to know the actual format or the syntax of the bytes. But I for sure need to get some feedback. I need to get some information, some metadata that we are going to, that it is also the one that it is the SVU needs to perform the linear selection.
So I think really focusing on what the gap between those, what the SFU needs to do a good implementation, what the other things need to do it is the right thing to do. And I don't think that the arguing, this is how we already implemented it, is really compelling for people here. Like, I think like really trying to get to the right design for Sframe is what we're trying to do here. So, I mean, pull apart those of what, you know, like the form of argument of the SFUs that are already implemented do it this way, therefore we have to implement the clients like this. Like, that's not very compelling. Both the SFUs and the clients need to change to implement Sframe. We're defining what both of them do here. So let's get the right design.
Yes, sure.
So unfortunately, we're out of time. I apologize to those people who just screamed and jumped into the queue. If you have something very quick, I'd like to give time now to Richard and encourage everyone to go to the AVT core meeting to discuss this further. Mr. Barnes.
All right. Am I audible here?
You have 10 minutes. Yep.
All right. Yeah, I have audio but no video. Sorry. So yeah, this is about Sframe and MLS, and thanks, Alex, for the queue up here. Next slide, please. I'm going to breeze through this pretty quickly. This should be pretty straightforward and non-controversial. So like Alex said, Sframe needs a way to get keys. MLS is a way to provide keys. In SRTP, we needed a way to get keys. We used DTLS to provide those keys. But DTLS is point-to-point. And for these conferencing cases where Sframe is really useful, we need something that does groups, that does multi-party key exchange. And that's what MLS does. MLS's core competency is that it does group stuff natively, unlike DTLS. So the idea here is to take this group key exchange primitive and kind of swap it in for the role DTLS plays in DTLS SRTP, and then take the keys that come out of it and use them for Sframe. Yeah, the bottom part here is just noting that we do have a working group deliverable on this, so we should probably adopt a document to fulfill it, and the proposal here is going to be that we do it with this document. Next slide, please. So there's really only two things in this document. It tells you how you take the keys that MLS generates for you and you put them in Sframe and put them to use, how you signal them, etc. We'll talk about that in a second. And then there's also some negotiation of other parameters that you need to use Sframe, how you negotiate those using MLS. Next slide, please. So on the keying side, if you look at kind of what Sframe needs, what MLS provides, Sframe, the encryption framing in Sframe requires a mapping where the sender and receiver can look up a key based on a key ID that is sent in the Sframe header. These keys that are used need to be unique per sender so that you don't have nonce reuse problems. So that you don't have different senders sending with the same key and nonce pair and have nonce reuse that can cause AEAD algorithms to fail. Now on the MLS side, what MLS provides is a sequence of group keys. MLS divides time into epochs. Whenever someone joins or leaves the group, roughly you get a new key, so that the people who left are locked out, the people who joined are let in. So you end up with a sequence of group keys. So you kind of need to map this sequence of group keys into the key ID space, and you also need to make them per sender keys and signal which sender you're using. So what the draft defines is like how you derive these per sender keys and how you signal them using the key ID field. Next slide, please. To do this, we just do kind of the obvious thing. For deriving per sender keys, we first export a key from the MLS context, exactly the same as DTLS SRTP does with TLS. They use an exporter to get a key. And then but the per sender keys are just derived by HKDFing things off of the that master secret, that epoch secret. The index that's input here is something we assume is configured. MLS, one of the things it also provides is an index. Each participant in the group knows what has a unique index of that participant's location in the group, so we can reuse that index here. And so we just encode that index and use it as an input to HKDF so that we get unique keys per sender. Then to signal the stuff in key IDs, we just take the two integers, we truncate the epoch to a certain number of bits, and we shift over the sender index by that number of bits and put that on the left-hand side. So we're using the the extensible nature of the key ID field. It's a variable length integer up to, I think, 64 bits. And taking advantage of that to put these numbers, two numbers in there instead of just one opaque number. Now, the idea of this E, this capital E number here, is that we're only going to carry a certain number of bits of epoch. I think something like, well, and that implies the fact that you're only using a certain number of bits implies that you're going to have rollover. That's okay. It's unlike, say, rollover of the sequence number in SRTP. What this epoch represents is which, it guides your key selection. So you're not going to have, say, nonce for use like you would have with sequence number rollover in SRTP. But it means you'll have decryption failures if you have a rollover and people aren't keeping up. So basically, this, the width that the application chooses for this epoch field is going to define how much reordering, how quickly people have to keep up with epoch changes in order to not have decryption failures. Since epochs only change on joins and leaves, it may not be a huge problem except during high churn times of the group. So yeah, I think we're not going to need a ton of bits here in practice, but I think that's something we can leave up to the application to manage. Next slide, please. The only other technical content here is negotiation of the aforementioned things. So obviously, if you're going to do Sframe encryption, you need a cipher suite you're going to encrypt with. The Sframe spec defines a collection of cipher suites that we just reference here. They have IDs, and it's a typical kind of offer selection paradigm as in TLS. The difference is that in MLS, the participants put this offer in a key package that describes their capabilities, and then when they are welcomed into a group, they find out what the group is using for the specific choices for these parameters. The only other parameter besides the cipher suite is the number of epoch bits. So the epoch underscore bits field here is the same as the E field, that number of bits in the epoch on the previous slide. So everyone needs to agree on that so that people can decode the key IDs. So we just signal that in this welcome extension. One more slide here, I think. Yeah, so we have implemented this key management part in the Sframe repo there. This is the scheme that we're working on putting into WebEx as we're doing the Sframe implementation there. Document-wise, I think it's pretty okay. It's obviously functional, at least to a basic level. I think Raphael was, I don't know if he's on the call this morning, he was thinking about adding some recommendations about how you manage the MLS groups that you use for Sframe. For example, if you have like a messaging group that you've got a long-lived MLS group for, and you're going to have a temporary MLS group just for a call associated to that messaging group, you might use some PSKs to connect those two groups and prove that the folks in the call were also part of the messaging session. So that's kind of advisory stuff for how you manage, kind of an extra meta level of MLS management. But I think mostly, like I said, at this point, it's pretty functional, and mostly it just needs to kind of stay abreast of Sframe as Sframe evolves towards standardization. And that's all I have. So yeah, I think this is in pretty good shape, and I would like to propose the working group take it on for that deliverable I mentioned at the top.
Thanks, Richard. Well, in the last minute, we're not going to be having a lot of opportunity to discuss this, but what I think we might do with this one is take that to the list, and we can have a discussion about that. It's unfortunate that the other work that we have sort of doesn't really exist, and so in terms of it's not formally adopted, so it's almost like putting the cart before the horse in a way, but we can probably have that discussion on the list. Looks good. And with that, I think we are all done. I notice my co-chair has arrived. Welcome. Thanks to our minute taker, Watson, who has produced some excellent notes here. And thanks to everyone for coming and having such a good discussion. Maybe next time we'll have more time to discuss. Bobo?
Yeah, thank you, Martin. Thanks also, Watson, for note-taking. My sincerest apologies. I saw the UTC +1 time zone and misinterpreted it as UTC. So here I am 3 minutes early for a meeting that's actually an hour late. I'm so sorry about that. Thank you, everyone, and I look forward to catching up with the notes.